Oh, you said it right, my name. So it's a difficult name to pronounce, but I'm Pankaj Attri. I'm a solutions architect. I work with healthcare and life sciences customers. I've been with SaaS 15 years now, believe it or not. But I've been supporting life sciences for the last 5 years. My background is in data science and data engineering and data management, and more recently, I can use this, more recently in generative AI and how to use the technology in healthcare. All right, so what I'll talk about is somewhat of a difficult topic, real-world data to OMOP. And I say difficult just because real-world data is messy. And it's easy to think that we can just create a generative AI solution and it'll do everything for us. That's not the case, but we'll make our first attempt. And then we'll talk about the challenges and then solutions around how we can use Gen AI, agentic AI, but then also use the modern data stack that's available for us. And then I'll do a demonstration of a prototype, right? So remember, it's a prototype, it's not an R&D product, but it's a prototype that will help us do the conversion from a real world to OMOP. And then, of course, we'll finish off with the adoption and business impacts. All right, I think everyone in the room knows here, whenever you have started working on a new project wherein you have received your real world data and you're trying to convert into OMOP, you, of course, start at the bottom in here where you have your governance and your standards taken care of, meaning you have your data use agreements in place. You know how you can use data, what purpose you can use the data for. And then, of course, you have your data coming in, which is your real-world data. Could be from a variety of sources, could be claims, registries, patient data. And then you ingest that data into your data analytics platform. And then as part of that ingestion, you do your cleaning of the data, meaning you make sure there are no missing values, there is no class imbalance if that's what's needed for your study. And once you have the data converted into OMOP, then you go into your last step, which is your exploratory and confirmatory analysis, which you can do either in your data science platform or you can use open source packages like R, Atlas, Hades. I'm sure everyone is aware of them. So what are the challenges? And of course, there are many, but these are the 5 that I could think of. Smaller bubbles represent, in my mind, a smaller problem in the cycle. And the first one is, of course, just the massive data scale and the space it needs to be uploaded in the cloud, the time it takes to run the ETLs. You have, of course, your de-identification concerns. It's patient data, so you have to make sure whatever data you are using is anonymized. Then there are semantic mapping and vocabulary complexities. You have data coming in from your hospitals, local lab codes, ICD-10 codes, blah blah blah. You know all the complexities that exist in this part. And then you have structural heterogeneity of the data. And by that, I just mean the same type of data can be stored in different types of tables in different hospitals, for example. Right? And then you have a lack of domain expertise in the sense that you don't have a single person who is a clinical researcher, but then also a data engineer and a researcher. Right? So there is handoff between different teams that just adds on to the time it takes to get to OMOP. Right, so how can generative AI and modern data stacks help us? So when I say generative AI paired with agentic AI, and I know these terms have been thrown out in the industry a lot, and I'm sure you have, over the past 2 days, you have heard about Gen AI and agentic AI. In my mind, it's very simple. All you're trying to do is you're trying to break a larger problem into very small problems. And then for each of those small problems, you have specialized LLM calls, which are enriched by context, which are now known as agents. Right? So you have multiple agents working on different parts of your problems. And then as those agents give you solutions, you sum up those solutions and you get the answer. Now, in our case, what we are going to do is we are going to use agents to do code generation, to also do ETL mappings generation, and then also do things like concept lookup in standard vocabularies. And then all of this has to be governed and automated with an expert sitting in between. The other part is, right, so that was the generative AI aspect of the solution. Right? The other part is the embedded analytics. So again, there are many terms in here that are thrown: SAS-Waya, DuckDB, Parquet, Iceberg, Vortex, Apache Iceberg. In a sense, all of these are newer technologies. Parquet, of course, is an older file format. But all of these technologies, what they enable us to do is to do at-source OLAP. Right? What does that mean? That essentially means that you're not really pulling in data from your cloud to your compute. You are running queries directly where the data lives. How does that help us? Now you don't need FX on tap, for example, right? You don't need expensive storage on cloud. You can just work with cheaper S3 storage and then still get even faster runtimes on your ETL queries, because Parquet is really fast. And using DuckDB to run Parquet, to run queries on Parquet files or Vortex files or Iceberg, Apache Iceberg is going to give you a lot of performance boost. And then, of course, you have SAS-Waya, which is your platform that is a GXP GCP compliant platform that runs your pipelines. Right. So we, as I said before, we created a prototype to test the hypothesis of whether or not using these two aspects of generative AI and modern data stacks can they help us get to OMOP faster. And there are three different, and I think I've briefly spoken about these, but there are three different features that we are going to look at in the prototype. Right? One is the data mapping aspect of it, right, which is where you are generating just English descriptions of your ETL transformation logic that you will eventually use to generate the SQL code. Right? And then, of course, the second part is then to generate the SQL codes that is based on the data mappings you create in the first step. And then lastly, you have traceability, which is really important, right? So how do you make sure you have visibility over what kind of reasoning did the agent work with, right? If there are any tool calls, right, what were those tool calls and what were the inputs and outputs? So all of this is there to provide you auditability and history of what you did when you were interacting with your agents through the large language models. Right. Briefly, this is the architecture. So you have SAS-Waya, right? So this is your data analytics platform. And the application, the prototype that I'm talking about is sitting in here. It, again, sits on top of the platform. And by that, I just mean that it exchanges data and it runs the code that the models generate on the platform. But then the application itself has access to large language models, and then large language models, in turn, of course, have access to MCP server, and then the server has tools. And those tools are nothing but tools that help the large language model to either look at things like concept lookup in standard vocabularies, or when you're generating code, then it can also look at your, maybe you did a project that was similar last year. If you wanted to have the model look at the code that was generated previously in that project, then you can use some of the tools provided by the MCP server. And then you have everything that gets created in the application gets stored in the database for historical auditability purposes. And then as an end user, you are accessing both the application, but then you're also accessing the SAS-Waya platform. So let's just see how the handshake works between the Waya platform and the application. Right? So you have claims data in the SAS-Waya platform. This is where you will do your data ingestion. There are a variety of data connectors available on the platform. But once you ingest the data, you also do data cleansing. Right? You make sure whatever is going in the next step of actually using that data to generate the ETL mappings is correct. And once you have cataloged your data, that's when the application comes into the picture here. This is where you are generating the ETL mapping logic. But to generate the ETL mapping logic, the application talks to the Waya platform, and then it pulls things like your raw data schema, which then it passes to the LLMs through MCP servers to get the mappings generated. And once you have the mappings generated, you then generate the code. The code generation has an error feedback loop, wherein if the code that's generated by the large language model in here is run on the platform, and then there is a back and forth that happens to get to a point where the code is runnable, right? And once you are at a point where the code is runnable, that means you have created your OMOP datasets, right? And once you have your OMOP datasets available, that's when you start doing your analysis, which could be doing your analysis in VA, or you could be using packages like Hades or Atlas outside of YAM. Right, so let's look at a demonstration. What I've done is I'm not doing a live demonstration. I've just done some video recordings. And I've used the synthetic data at Cynthia for this demonstration. Right. I'll go back here because I need to pause the screen. Okay, so what I am doing in here is I've logged on to the Wire platform, and I'm trying to make a data connection, right? So I am in managed data mode. This is where you are seeing all the data connectors that are available for different data sources. My data is in A3, so I'm creating a data source for A3. I'm just specifying the name of the library. Library is nothing but a connection to my data source. I'm specifying more connection strings that I need to be able to connect to S3. And then I've created, too fast. I've created my, so I've created my connection, right? So Sin100 here is nothing but a library name, and this is pointing to an S3 bucket, and the bucket has these data sets, raw real-world data sets in it. So at this point, I've created my data connection, but what do I do next with it? I can, of course, look at my sample data, make sure everything looks correct, but then I go into something called an information catalog, right? So think of information catalog as a space in Wire wherein you are running data crawler jobs. What do I mean by that? So when you have your raw data stored, the data crawler jobs actually pull metadata for your data sets. In this case, all it's doing is it's looking at all your real-world data sets, and then it's giving you more information about what kind of data is in there, what kind of metadata exists in those data sets. Right, so I'm looking at my library. In here, I'm looking at my patient data. Let me pause this. Right, so I'm looking at my patient data. My patient data has so many columns: ID, birth date, death date, SSN. The information catalog has automatically already mapped that some of these columns have private information in them, right? And if it did miss any of this, of course, you can go ahead and change the semantic type for some of these columns. Now, why is it important? I'll come to that later on, but just keep in mind that when you are running the data crawler jobs on your raw data sets, it's able to map your columns, and it's able to identify whether or not some of these columns contain privacy information or not. Right? So that's one part of information catalog, right? What's the second part? You can then look at additional column details. So I think I'll go to column analysis next. Oh, well, yeah, so I'm going into gender in here, right? So I can see that there is not a whole lot of class imbalance in here. Oh, here. So now I'm looking at my race column. There is imbalance here. Maybe it's not really a concern for me for what I'm doing. But if you were, I don't know, using the OMOP data for a modeling perspective, then maybe you need to look at your data sources and do some corrections. And how do you do that? Right, so I am now also looking at the data quality measures, right? So for each of the columns, I can see if there are any outliers, what are my min-max values for each of these columns. Now I'm looking at encounters. Same thing, I have information privacy details, I have data quality details, and then I can either explore or visualize some of these tables, or I can open the table if I wanted to make some changes, right? And at the point where I'm okay with this data set going into the next step, I mark the data set as approved. And then I go back to my data connection and just make sure that whatever permissions I need to specify are specified on the data sets. What does that mean? Who gets to see what, right? So if there is patient data and there is other encounters data, and I only want a certain team set to have access to this, I can control who gets to see this data. And this access control can be at a very fine granular level, even at column and row level. But after I've approved my data sets, after I specified permissions, then I go to my next step, which is now to go ahead and start moving on to the prototype. Right. So far I was in SAS Via. I connected my data sources. I analyzed my data. I made some changes if I needed to. But I am now at a point where I have sort of approved what needs to go in the next step. Right. So now I'm in the prototype screen here. I do my login. This, of course, is logging in on the same Via platform. And then you see a list of projects. Think of projects that you would create for a new data set that has come in and you're trying to format it to OMOP. Very simple screen on when you say create project, you provide your project details, your project description, and then you choose your library name. This library name is nothing but the names of the library that I created in Via and that I have access to, right? And the data sets that appear on this list are only the ones that were marked approved in information catalog. So I'm selecting allergies, conditions, devices, all these data sets. And when I am done with this, I go to my next step. Now, notice here that the file type, it has already identified that the file type is Parquet. It has already identified where my files are living. And then the CDM folder and the program folders, these are just the names of the folders where I want to create my final data sets in. Right? So OMOP CDM is just the name of the folder, which I can, of course, change and specify where exactly do I want the final data sets stored on my NFS type that's exposed to Via. And similarly, the programs is just the name of the folder where the programs get stored. Right, then I go to my next tab, which is data standardization. Right, so this is where I'm choosing what kind of CDM version that I want to work with. This is only supporting the most recent CDM version. And then I am selecting what OMOP CDM tables I want to map data to. If you did not select any in here, which is a valid choice, then it will try to map to all available CDM data sets. But in here, I am choosing person, observation period, visit, visit tables, and some other tables. Okay. Right, and once I'm done with that, this is where I am specifying what large language models do I want to work with. Now, keep in mind that these large language models are the models that I have access to, right? So if this is something that's used within your organization, this will be a list of models that you have access to. This is not just a random list of models that are available out there. And we have split the models into two different. So there's one base LLM, which is like your master LLM, and then you have a code LLM, and both of them could be the same. But in case you have some fine-tuned LLMs that you wanted to point your that you wanted to use for code generation, you could do that. You could choose a different model. Now, on this screen, once you've created a project, right, there is on the left-hand side you have these data transformation steps. And, these are nothing but the first one is where you create a high-level table level mapping, and I'll explain it more. And then you create your mappings in here. Then you create your DAG, which is like in what order you want to create your CDM data sets. And then you generate your code. And then as part of generation of the code, you get the data sets, you get the code, and then you mark the project approved in the last step. And then on the right-hand side, you have different tabs. As and when you start completing some of these steps in here, information will start to pop in, which of course is editable for you to look at before you move on to the next step. Right, let me go to the next step. So just backing up, we had data sources. We connected the data source to Via. Then we moved on to the prototype. I've created a project, and I've specified where my data lives. And then in the next step, I'm going to here. All right, so now in this step, what I am doing here is, let me play this video. Right, so what I'm doing here is something called so let me pause this. So I am doing a high-level table mapping. Now, what does that mean? So if I have my data, let's assume I have my payer transactions where I have details about the healthcare coverage that's provided to patients, but I also have other data sets like my encounters, right? So it depends on what exactly is it that you're trying to do. If your project entails looking at encounters and then using encounters to define your observation periods, then you can choose to use encounters. Or if you wanted to look at your healthcare coverage on your patients, then you can choose to look at a different table to map to your observation period, for example, right? So all we are doing in here is, at a very high level, we are asking the model to look at all the raw data tables, right? And then I already know which CDM tables I want to map to, but then I'm asking the model, and of course there are predefined prompts written in the backend, and then I'm asking the model to return what it thinks I should be using at a table level mapping. So the first step in here is to retrieve my raw data. This is where the control is going back to my to SAS-Viya to retrieve the raw data schema, and this is where I am making sure that any data that was classified as privacy is not returned back in here, and I'll show you how that looks in here. But the first step is retrieving my raw data schema, and once that is done, then, and I think I'll speed up this process. So this usually takes around 10 minutes, 10 or 15 minutes, but once this completes, this essentially means that the model has generated a high-level table mapping for me, which I can then review and edit before I go to the next step. And then in the last step, I'm just saving the assessment to a project. So I'll close this, and then this is what the screen now looks like. Right? You have making more space in here. You have filters in here. So anything that's in gray is my raw data set. Anything that's in blue is my CDM data set. Right? Now, I can either expand in here, or I can expand the graph to get more space in here. And now I'm looking at raw data sets. Now, when I click on my, where did I click? OK. I click on this. OK. All right. Now, what I am doing in here is I'm just looking at my raw data sets, and I'm looking at my payers data set, and I can see some of the columns have redacted, are redacted because they contained privacy information, right? So this is where what we did in information catalog becomes useful, right? So this data then is not, one, seen by the end user, but then two, is also not sent to the large language model when we are asking the model to do a high-level table mapping. Right, so I'm just looking at my raw data schema in here. I can look at my, and this is not, of course, pulling everything. It's just pulling first 50 rows of my data set. And then for each data set, target data set, I have two different sections of information that I am asking the model to provide me feedback on. Right? One is a very high-level pseudo ETL plan. Right? So I'm asking the model to say, well, look at the raw data schema and then tell me what could be or should be my primary source and what could be my supporting source as my data source for this pair plan period. And it has come back saying, well, based on what I see in the data, I think pair transitions should be your primary source, and pairs and information in your patients should be my secondary source. And you have some pseudo ETL code that the model has written. Now, all of this information is one, editable, but then becomes useful in the next step, where then when I'm asking the model to retrieve or to generate data mappings, I'm not passing all the data sets, but I'm only passing certain data sets to reduce the hallucinations and not have the model to look at all available data sets, but only look at a certain subset of data sets that I want it to base my mappings on. OK, so I think on this screen, I just looked at, I think I clicked on the cancel button. I think now I'm looking at my other tables, looking at my patient table. Again, there are more redacted columns in here. And then I think I'm going back again here just to make sure. I was doing this live, so some of this might be repetitive. But all I'm trying to do in here is make sure at a very high level that whatever information is there is correct. I'm looking at my patient table. There are no supporting tables. Of course, everything is in patient table. And then I'm looking at my observation period. So same thing. All I'm doing here is making sure whatever is returned by the model is correct. So I'll skip all of this. I'm essentially doing it on all tables. I can, of course, do filtering to only look at certain set of CDM tables. But once this is done and this is complete, then I'm back to my screen where this essentially means that I'm OK with the high-level table mapping that I've created. Right? Now, what do I do next? I then take this information on each of these data sets, and then I go to my data set mappings. So I then will click on the next button, which is, not this one, in here. Right. So what I'm now doing is I'm just clicking on the start button for the next step to begin. Right. So what is this? Again, when I am generating mappings, right? Of course, I need to have the raw data schema generated again, but that's already been generated in the previous step. So that step completes faster. And now for each of these data sets, like person, observation period, visit occurrence, you have these completed, in progress, pending markers in here. So as and when the information, as and when the model finishes creating the mappings, it changes the status. But then notice that for each completed table, it has an initial string of what the reasoning logic was to get to observation period mappings. But then it also has this view reasoning and tool trace links for each of the models, for each of the tables. Let me go into this part here. Oh, no. Okay. Right. So what I'm doing in here, so all of this is finished. Now you will notice that when this is finished, right, you have the table level mappings created in the backend. But in here itself, right, I can still on this screen itself, I can see my the reasoning logic that was used and any tool calls that were made to get to the mappings for each of these tables. So if I click on this, there are two different tabs. This is just the reasoning logic of the model, and then you have the tool calls. So there are two different tool calls in here, right? One is make sure that if you are, so right now I'm in visit details, right? The clinical concept in visit detail is just the visit name. So what it is doing is it's first performing a standard concept match, and then if it's not able to find standard concept match, then it's going to do another tool call to get alternate concepts for any unmatched terms, right? So this is just giving me an overview of what tool calls were made and what kind of results were retrieved. And I'll show you more in details later on. But on this screen, I'm just showing you that this is the auditability aspect of the solution, wherein you can see why certain decisions were made. Now, on this screen here, this is just a raw data coverage map, and I have two different tables in here where there's a list of tables, raw data tables, and a list of CDM tables. And then this is just listing the columns in each of these CDM tables for which I did not find any raw data mappings. And then on the right-hand side, you have more mapping details. Again, anything that's in blue is CDM target, and anything that's in gray is my source. Right, so in here, now what I'm doing here is, because this is too much information, I can zoom in to each of my tables. I can remove some tables from my view to get more space. And then for each of the CDM tables, so for each of the CDM tables, I have 3 additional buttons, right? So I have the matched source concepts, I have unmatched source concepts, and I have mapping model trace. Now, this mapping model trace is nothing what you saw in the initial screen, where it's just going to show you the reasoning logic, and it's going to show you the tool calls that it made. But then this matched source concept and unmatched source concepts, these two tabs actually are going to show you the results of the tool calls, right? So the first thing that the model is doing is it's looking at the raw data set that's feeding visit details, and then it's looking at the column that should be used as a clinical concept to look for the standard concept. And if it does find any matching, so I'm just showing you it's the same thing, but then I'm looking at the source concepts. In here, there's a visit and a visit not. So visit not is all concepts or strings for which I did not find any matching terms. And in here, this is the second tool call that was then made. So what's happening here? Ambulatory, emergency, home, hospice, these are terms for which the tool did not find any direct standard concept. So what it did was it then generated some alternate strings, right? In this case it only generated one alternate string. and then it tried to search for outpatient visit, and then it found one, either a direct ancestor of this term, or one or that term in itself, if that term was the standard concept. And then you have additional column details in here, which is giving you the names of the alternate term, or whether or not that alternate term is standard, and then the target domain names. Right, so I'm now just scrolling down for hospice. It searched on hospice. For inpatient, it searched on hospital inpatient. And then for each of these search terms, it then retrieved additional standard concepts that I could choose from. So if I scroll to the right in here, I can then choose, well, for if I did not find a direct standard concept for inpatient, maybe for inpatient visit is what I can choose for this, this project. Now, after having chosen my alternate concepts, what I can then do is I can either save those mappings for the project, or I can save the mappings to the repository, so that these custom mappings are then used everywhere else in the project, in new projects. Right, so I'm doing, then I think I'm doing the same thing. Okay, now I'm looking at procedure occurrence. Again, same thing. You have match source and not mapped concepts. Then I'm looking at the alternate concepts that I could potentially use. I have the option to choose one of these for each of the unmapped concept. I can choose to save to project or to repository. And then let's look at some field level mapping. So right now I'm looking at procedure source concept ID. So what I've done here is when I've asked the model to create mappings, right, I've asked it to create a pseudo SQL logic. Now, some of this logic can be hard to understand, so there's always a English description of the logic. So all it is doing here is when it's looking at the source concept ID, so when it's looking at the source concept ID, all it's saying is, look at the source to standard mapping, which is a vocabulary that I've already created, but then it's matching the source code in this vocabulary to the code column in the procedures table. And then if it is found, then you use that ID. If it's not found, then just use 0 for that standard concept. And then I'm essentially doing the same thing. I'm just making sure that for all the fields, the mapping is correct. So 32817, it has identified that the data looks like EHR data, so it has just given me a type concept ID of 32718. And then I'm just verifying the metadata, the mapping rules that were generated for all other fields. Okay, I'll skip this. Okay, let's go to the, so once I've verified that everything looks good on the mapping screen, then I'm going to use this in the next part, which is actual code generation. I know I have only 5 minutes, so I'll speed up. Right, so on this screen, the first thing that I'm doing in here is I'm creating a DAG, right? There is dependencies on CDM tables, so I'm making sure that I start with the lowest common denominator location, and then I'm changing the dependencies to suit what. So in here, I'm choosing visit details to be created first before visit occurrence, which might seem odd, but we have kept it simple, and all we are doing is we are just taking the first record from the visit detail as the visit occurrence record. Once I've created my dependency graph, then I go in and then I click on my next button, which is to generate SQL code now. This is proc SQL code. Again, very similar screen that you saw before, but in here you are, this takes around 30 minutes, too soon? Okay. Now, when this is complete, right, so you have this view history for each of the tables, right? So it's actually showing you the code version history, right? So this when it was creating visit details, it actually tried 4 different versions, and you can see the differences in the 4 different versions. I mean, you can compare differences between any 4 different versions, and you can see that when it tried with big int versus int, it finally succeeded. And then you can essentially look at the history of not just the code history, but also any tool call history or the reasoning that was used to generate the code. Okay, I'll skip. Okay, now on this screen, when the model finishes what it needs to do, you will notice that there are multiple subtabs in here. Right? Each of these subtabs are CDM datasets, and then for each subtab, I have multiple subtabs. Right? So code tab, of course, gives me the proc SQL code. This is a DuckDB compliant SQL code that's running on Parquet files. But then you also have the last run log, and then if any output was generated. Right? And then you have this success message displayed if on the last run this code execution was successful. There are additional options on the screen. If this had failed and you wanted to make changes yourself, you can do two options. You have two options. You can either edit the code yourself and then run the code right from here, or you can regenerate this code, ask the model to generate the code again, and give you a new version. And then, of course, you can also look at the table. So yeah, this is just looking at the history. And now I'm looking at the table preview of the actual OMOP dataset that was created as part of running this code. So once this finishes, this is just a preview. Again, first 50 rows of what was created for care site. And then you can do the same thing. This is persons. You have history, the same history that we saw earlier. I think this is where the model maker made a mistake last time in the path, but then it corrected itself and it finally ran. And then I can look at my table preview for person. Okay, I'll skip. Right, now once this is done, right, once everything is succeeded, meaning I've created all my data sets, what I do is I mark this step approved. And what this then does is then it takes the control back to the Wire platform, which is where all the data sets that I had created. Remember, when I had created the project, I had specified OMOP CDM as my folder. And then within that folder, there is a programs folder, right? So all these are Parquet files, CDM data sets, and within the programs folder, these are all SAS files, which has the proc SQL code for all the data sets that it used to generate. Right. Now, once you're at a point when you have the OMOP data sets created, right, you can begin your analysis either outside or within SAS. Now, all of this looks good, looks fancy. Does it really work, right? So we again tested this on Cynthia. The results are good. I mean, just looking at by numbers, I won't say that this just works. But this is our first attempt, right? I mean, we have to start somewhere. And even if this gets you 50, 60, 70% of the way, I think this is good enough, right? Large language models and agents and agentic AI, generative AI is not at a point yet where you can just 100% believe what it spits out, right? But it is at a point where you can significantly use to reduce the time it takes you to get to OMOP, right? Now, what failed in my testing, right? It failed when it did not find any concepts in the standard vocabulary. More importantly, it failed when it was not able to maintain referential integrity. Meaning, if there was a patient ID and that's available in patients, then it did not really use that patient ID. It created a hash from another table, right? So those kinds of errors I did find in the final data sets. And why? I think just lack of expertise on my side. I didn't really spend a whole lot of time in making sure that the mappings that were generated were correct or not. But there is potential on improving that. Okay. Amit, done? 5 minutes? Okay, thank you. All right, so how do you make sure that this is usable, right? I mean, over the past 2 days, I've had so many conversations with customers where there are so many privacy concerns. Right? How do I use it? Right? I mean, even if I wanted to use it, my organization is not letting me use it because it's patient data. I don't want to send my patient data up to somewhere, right? So I think at some point we have to start small, and we have to start in a regulated environment. Right? IT and other organizations, your legal, your regulatory affairs have to be comfortable that the data that you're exchanging with the models is not really patient data. You have redacted as much as you can, and whatever data you are passing is still within your organization's VPC hosted LLMs. and how do you make sure that the results that you're getting is trustworthy, right? Of course, expert in the loop, I'm sure you have heard it so many times now, but this is needed, right? Even after 5 years down the line, when this is going to work perfectly, I think we will still need an expert to make sure that whatever is getting done is correct or not, right? Governance and security, always make sure you scrub your PII. But then the second one is more important, right? Intent logged scope, right? And how do you build this, right? So in what I showed you in my prototype, you might have noticed that there was no chat interface, right? And that was on purpose, right? Because what I'm trying to do is I'm trying to make sure that the users of the applications not inadvertently or by mistake, paste patient data, for example. But then I'm also making sure I am able to make sure that I am able to use generative AI in the backend, right? So all you have in the screen is just button clicks, but in the backend you have agents and you have prompts that are helping you get to your OMOP tables faster. And then how do you responsibly adopt? Removing bias, quality issues, again, this is not related to this prototype. This is just generic stuff. But then there are predefined prompts in absence of free text chat interfaces. Business impact, this is the last slide. This is nothing specific to real world or OMOP transformations. I think anywhere we use generative AI, and we have to see these new technologies as assistants and not really things that will replace us. Maybe 10 years down the line, who knows, but not yet. And the whole idea here is to compress timelines, right? And not provide a turnkey solution, but just to give you a jumpstart solution, right? As I said before, we are not there yet where we can just get everything out of this 100% correct in the first run. And then relocate the expertise, right? We spend so much, we spend months in just creating OMOP data sets. Even if we can reduce the timelines from 3 months to 2 months, right? I mean, that's still a significant gain of a month timeline. Oh, that was fast, okay. Well, I'm done, thank you. I took 3 more minutes of your time, apologies for that. Yeah. Any questions?
Anybody have any questions?
Yeah, so this is awesome to see. I'm wondering if you had considered bootstrapping the front end with essentially some kind of agentic data cleansing as presented by someone who's also here in the audience as well.
That's a nice idea. No, I have not thought about that. I think my starting point of using this application is they've already done all of that in Vaya, right? But not really in the application to make sure that you are doing data cleansing within the prototype.
But do you see then, so the MCP server that you were using here, it was able to, I mean, from what I'm seeing that you're presenting, it was able essentially to choose and select what functions in its toolbox to run in order to create the right kind of code in order to do the mappings. But there was an interface I think I saw there for essentially taking the next step as like a manual intervention and correcting whatever the machines were not able to do. Then.
Yeah, I mean, so you can potentially see it as a new tool that does data cleansing for you, right? But then I think in my mind, it's just handing too much over to Gen AI. And I think I'll be more comfortable in doing data cleansing because that's an important thing within Vaya to begin my OMOP mapping. But I mean, technically speaking, yes, it is possible. Yes.
Thank you.
Thank you. Thank you for the nice presentation. I think also it was similar, the earlier presentation with Matt Becker, correct, on the clinical mapping earlier today?
Yes.
Used kind of same prototyping that you have been doing here?
Yes.
I maybe missed it because I was a few minutes late in the beginning. But is it, do I understand that it's today a prototype or
this one is still a prototype.
Is it the intention that it gets ultimately in clinical acceleration or in another product or in SaaS health? Or
that is the hope. I think it's still in a very nascent stage. There have not been any, I mean, we have not really implemented it for a customer. There has been interest and we are pursuing that. Once this is at a point where we see more interest from the market, then of course, R&D is going to pick this up and then bring it in CA, hopefully.
Okay, yeah, we can follow up separately. Yeah.
questions? Okay. Cool. Thank you guys for coming.
Thank you, guys.